Okay, this NATEP 3 project is a materials-based project, and we're developing a new material that can't be found in nature. And the reason I'm standing in front of this fume hood is because we're dealing with various ingredients that are quite sensitive in terms of airborne particulates. So we need to keep everything locked away and out of harm's way to protect the user. So what we're trying to do is develop a new composite material that is a combination of multiple different components. So we've got at our disposal a number of different magic ingredients, if you will. They're all held together in some kind of binder, and what we're doing is we're systematically trialling our way through certain recipes, testing them at the University of Exeter with the team at Physics. This is Professor Alistair Hibbins and Dr. Paul Keatley, Professor Roy Sambles as well. And we're characterising those materials, feeding that back into manufacture and adjusting, so it's an iterative loop. Now we're only making small samples at the moment, we're only using small moulds like this. The end goal is having a material with magnetic and electrical properties tuned to our requirements. Now, why is that important? What it gives the end user is effectively the opposite of a magnifying glass, and it allows us to shrink various components. So the materials that we'll develop in this project interact with electromagnetic radiation in a particular way. That allows us to work with things like antennas, communication equipment, and make them much, much smaller. So this project actually springboards off the back of a previous project I've worked on, quite separate technologies, but now rather than looking at a sort of Z height change in size, we're looking at a Z, an X and a Y, so we're shrinking something in 3 dimensions. And this is really attractive to our end users because they could get more equipment in one given space. They can obviously make them smaller and lighter, and the environmental benefits are multiple in terms of size, fuel burn, and maintenance, repair and operation. We've got quite a long way to go yet, but it's an extremely exciting project. It allows a small SME like myself to work with an internationally renowned team of researchers at the University of Exeter, and our end user is extremely interested should this technology work, because 1, they've got a number of immediate applications for it, and 2, just as important, it gives sovereign capability to the UK. We can make this material within our control and supply that for whatever application we want to.